Dear students, welcome back. In previous class we discussed about the limit of certain sequences, and we say that sequence n is a divergent sequence. Sequence minus 1 power n into n is also divergent. Now, what about the sequence 2 power n? Is 2 power n convergent? So how? 2 power n means we know that 2 power n greater than n for all n greater than 0. 2 power n greater than n for all n greater than 0. And what about sequence n? Sequence n is a divergent sequence as well as sequence n is unbounded. Sequence n is unbounded. Since sequence n is unbounded, we know that sequence 2 power n, sequence 2 power n greater than n, but sequence n is unbounded, therefore sequence 2 power n is not convergent. Agree? Okay. What about sequence minus 1 power n into n square? Sequence minus 1 power n into n square. We know that modulus of minus 1 power n into n square equals n square. That is strictly greater than n. Okay, but sequence n, what is sequence n? Sequence n is again unbounded. Therefore, sequence n square is unbounded. Hence the sequence minus 1 power n square is not it is not convergent. Enough. Okay. So like this, we prove the convergence and divergence of different types of or different sequences. Now, let's consider another problem. Find the limit of 2 plus 1 by n whole square. What is the limit of, find the limit of 2 plus 1 by n whole square. How to find this limit? For what is means this left side equals, it is the limit of 2 plus 1 by n into 2 plus 1 by n. What is the limit of n tends to infinity 2 plus 1 by n? Limit 1 by n, since 1 by n is sequence 1 by n. What is sequence 1 by n? That tends to 0. Therefore, it is 2 plus 0 into 2 plus 0. That so it is limit 2 plus 1 by n whole square is 4. Agreed. Now, how to find out limit of minus 1 power n by minus 1 power n by n plus 2. Find the limit minus 1 power n by n plus 2. How? So far, we know that minus 1 by n plus 2, it is less than or equals minus 1 power n by n plus 2, less than or equals 1 by n plus 2. Okay? Yes. We know that minus 1 by n plus 2, less than or equals minus 1 power n by n plus 2, less than or equals 1 by n plus 2. Now, what about sequence minus 1 by n, limit of, what about limit minus 1 by n plus 2? Limit minus 1 by n plus 2 is always 0. So, therefore again, limit 1 by n plus 2, that's also equals 0. So, these two are zeros. So, by Squeeze theorem, limit an, let an is sequence, let an equals sequence minus 1 by n plus 2 and bn equals sequence 1 by n plus 2. So, by Squeeze theorem, we have limit an equals limit bn. Limit an equals limit bn. Here an less than or equals zn less than or equals bn. When limit an equals limit bn, then limit an equals limit zn equals limit bn. Therefore, limit zn, what is zn? Minus 1 power n by n plus 2 is 0. That is true by Squeeze theorem. Agreed. So, limit of minus 1 power n by n plus 2 equals 0. That is proved by using Squeeze theorem. Agreed. Okay. Now, find the limit of n plus 1 by n root a. Limit n plus 1 by n root a. How to find this one? Limit n plus 1 by n root n. This can be rewritten as limit n by n root n plus 1 by n root n. Agreed? Okay. So that equals it is limit 1 by root n plus limit 1 by n into 1 by root n. What is limit 1 by root n? So it is 0, means it is 0 plus 0, so it is 0 itself. Okay. Consider another one. If 0 less than a less than b, if 0 less than a less than b, find limit a power n plus 1 plus b power n plus 1 divided by a power n into, a power n plus b power. Find if a lies in between 0 and b, then find limit a power n plus 1 plus b power n plus 1 by a power n plus b power. How? So here a power n plus 1 plus b power n plus 1 by a power n plus b power n can be rewritten as, it is a power n plus 1 plus b power n plus 1 by a power n plus b power n into 1 by b power n by 1 by b power n. Can introduce 1 by b power n by 1 by b power. That's one. So that can be rewritten as a power n plus 1 plus b power n plus 1 by b power n plus 1 all divided, as b power n all divided by a power n plus b power n by b power n. Enough? So that equals, it is a power n plus 1 plus b power n plus 1 by b power n. Then here take a power n outside. So what do you get? It is a into a by b all power n. That is a power n plus 1 by b power n can be rewritten as a into a by b all power n plus b power n plus 1 by b power n. That is b all divided by a power n by b power n. That is a by b all power n plus b power n by b power n. That is 1. Term by term splitting. A into a by b all power n plus b by a by b all power n plus 1. Okay. If we know that if 0 less than c less than 1, then what is limit c power n? Then limit c power n equals 0. This is a non-result. If 0 less than c less than 1, then limit c power n equals 0. Since 0 less than a less than b, that means 0 less than a by b less than 1. So therefore, by using this argument, limit a by b all power n equals 0. So if you taking limit on left side, so it is left side equals, if you take the limit, then limit of it is a into a by b all power n plus 1 divided by a by b all power n plus 1. So plus b divided by a by b all power n plus 1. We know that limit a by b all power n equals 0. So here 0 into a plus b. So it is b by 1. So answer is b. Therefore, limit a power n plus 1 plus b power n plus 1 by a power n plus b power n equals b when 0 less than a less than b itself. Enough. Okay. Now, we consider another problem. Use Skew's theorem. Determine limit n power 1 by n square. Skew's theorem. Determine limit n power 1 by n square. What is Skew's theorem? Skew's theorem states that xn, yn and zn are any three sequence of real numbers with xn less than or equals zn less than or yn less than or equals zn, and limit xn equals limit zn, and then sequence yn converges, and limit xn equals limit yn equals limit zn. That is Skew's theorem. So using Skew's theorem, determine the limit n power 1 by n square. How? So for Skew's theorem, you can find any two sequences, sequence an and sequence bn. You can find two sequences, sequence an and sequence bn, such that in order to apply the Skew's theorem, such that an less than or equals n power 1 by n square less than or equals bn. So whereas limit an equals limit bn, you can find out sequence an and bn which satisfies these two conditions. In order to apply Squeeze theorem, you have to find out two sequences an and bn which satisfies the conditions an less than or equals the given sequence n power 1 by n square less than equals bn. Moreover, limit an equals limit bn. So how? We have, we have 1 less than or equals n. Sure? Yes. 1 less than or equals n for all n following n. So that means 1 less than or equals 1 by 1 power n square, or 1 equals, this 1 can be rewrite as 1 power 1 by n square. Agreed? So, but 1 less than or equals n, so it is less than or equals n by 1 power n square. Enough? That means 1 less than or equals n power 1 by n square. Agreed? So choose sequence an equals 1. Sequence an equals 1. That means limit an is again 1. Okay, right. Now, again, choose bn. So, choose another sequence bn. We have n square greater than n for all n following n. N square greater than n. That means 1 by n square strictly less than 1 by n. This is true for every n following n. 1 by n square strictly less than 1 by n. So, 1 by n square strictly less than 1 by n means 1 by n square, therefore n power 1 by n square strictly less than n power 1 by n. Okay? For all n following n. Since 1 by n square less than n, since n is a natural number, so surely n power 1 by n square less than n power 1 by n. Why? If a less than b, n power a less than n power a. Okay? For every natural number n. Then choose bn. So here you choose bn. Bn equals sequence n power 1 by n. Choose n equals sequence bn equals n power 1 by n. What is the limit n power 1 by n? We know that limit n power 1 by n equals 1. Already proved that limit n power 1 by n equals 1. That is limit n power 1 by n means limit bn equals 1. So an and bn are choosing such that, so by Squeeze theorem, here limit an equals limit bn and an less than or equals n power 1 by n square less than equals bn. So by Squeeze theorem, limit n power 1 by n square equals limit an equals limit bn, that is 1. So limit n power 1 by n square is 1. Agreed? So in order to apply Squeeze theorem, we have to find out two of the sequences an and bn which satisfies the condition an less than or equals the given sequence less than or equals bn with the limit an equals limit bn. Then you can construct an and bn in such a way that limit an equals limit bn equals 1. Then you can apply Squeeze theorem. Enough. So come to another one. Use Squeeze theorem. Find limit n factorial all power 1 by n square. Limit n factorial all power 1 by n square. Again, find the limit of given sequence by using Squeeze theorem. Limit n factorial all power 1 by n square. How? Again, we can choose here an and bn. Sequence an and sequence bn such that an less than or equals n factorial all power 1 by n square less than or equals bn with the limit an equals limit bn. Okay. So far we have 1 less than or equals n for all n following n. So that means 1 less than or equals n. That means here, so choose an equals choose an and bn with the an less than or equals that 1 less than or equals 1. So what is 1? Again 1 equals 1 equals 1 power 1 by n square, which is since 1 less than or equals n, it is less than or equals n by, n power 1 by n square. N power 1 by n square also less than or equals n factorial all power 1 by n square. Why? Because n less than or equals n factorial. Agreed? Okay. So here, moreover, it is 1 less than or equals n factorial all power 1 by n square. That is secants an equals 1, then limit an equals 1. Agreed? Now choose Bn. We know that n factorial less than or equals n power n. N factorial less than or equals n power n. Why? Because what is n factorial? N factorial means 1 into 2 into etc. into n. Okay. So this is less than or equals n into etc. into n. So n factorial less than or equals n power n. That means n factorial all power 1 by n square less than or equals n power n all power 1 by n square. Okay? Yes. That means n factorial all power 1 by n square less than or equals it is n power 1 by n. 1 n cancelling, so it is n power 1 by n. Therefore, choose Bn. Here Bn, choose Bn equals n power 1 by n. So what is limit to Bn? Limit to Bn equals 1. Agreed. So we have an less than or equals the given sequence less than or equals Bn with the limit to Bn equals 1, limit an equals 1. Therefore, limit of the given sequence is 1. Means limit n factorial all power 1 by n square is also 1. So this is therefore means this can be proved by using Skew's theorem. So far, find out the limit of a sequence by using Skew's theorem. You have to find out the two sequences an and bn such that an less than or equals the given sequence less than or equals bn with the limit an equals limit to bn. So that is the requirement. Enough. Now come to your result. If sequence xn be a sequence of positive reals, sequence xn be a sequence of positive reals such that limit xn plus 1 by xn equals L exists. If L less than 1, then secant xn converges and limit xn equals 0. So this is an important result. If secant xn be a sequence of positive real numbers with limit xn plus 1 by xn equals L exists, and if L less than 1, then secant xn converges and limit xn equals 0. How? The proof is in this way. Come on. That is xn. What is xn? Secant xn be a sequence of real numbers. Secant xn be a sequence of positive real numbers. Means secant xn greater than 0. Okay. Secant xn strictly greater than 0 for all n following n. Therefore, xn plus 1 by xn, secant xn plus 1 by xn greater than 0 for all n following n. Then we know that if secant xn be a sequence of positive real numbers, then limit xn greater than or equals 0. Therefore, instead of xn, here it is xn plus 1 by xn. So it is xn plus 1 by xn greater than or equals 0. That means what is limit xn plus 1 by xn? It will be L. Therefore, L greater than or equals 0. Agreed. Now come to the given condition. If L less than 1, then we have to prove that xn converges and limit xn equals 1. L less than 1 but L greater than or equals 0 means 0 less than or equals L strictly less than 1. Enough. Therefore, there exists some R such that 0 less than or equals L less than 0 less than or equals L less than R less than 1. Since 0 less than equals L strictly less than 1, there exists some R such that 0 less than or equals L less than R less than 1. L less than R less than 1 means R minus L is strictly greater than 0. L less than R means R minus L is 0. But epsilon is positive. So put epsilon equals R minus L since R minus L is positive. But what is limit? Limit is given limit xn plus 1 by xn equals L. That means for all epsilon is positive, modulus of xn plus 1 by xn minus L strictly less than epsilon. So for all n greater than or equals some k following n by definition. So that means L minus epsilon less than xn plus 1 by xn strictly less than L plus epsilon. Come to the right side inequality, that is xn plus 1 by xn strictly less than xn plus 1 by xn strictly less than L plus epsilon. From here, what is L plus epsilon? L plus epsilon equals R. Here L plus epsilon equals R. So that means mod xn plus 1 by xn strictly less than R. That means xn plus 1 strictly less than R into xn. Okay. So it is true for every n greater than or equals k. So that means xk plus 1. Xk plus 1 strictly less than R into xk. Agreed? What is xk plus 2? Xk plus 2 strictly less than R into xk plus 1. But xk plus 1 strictly less than this one. So it is equals R square into xk. So xk plus 2 strictly less than R square into xk. Now therefore what is xk plus 3? Xk plus 3 strictly less than R cube into xk. Proceeding like this, what about xn? Xn strictly less than R power n minus k into R power n minus k into xk. That means xn strictly less than R power n into xk by R power k. R power n minus k means R power n divided by R power k into xk. Okay, n minus k. So xn strictly less than R power n into xk by Rk. Means put a C equals xk by Rk. Xk by R power k. But what is R? R also less than 1. 0 less than R less than 1. Since 0 less than R less than 1, then we have formed, that limit R power n equals 0. So if we take limit, so it is limit xn x power n, it is equals it is strictly less than limit R power n into limit xk by rk. Since clearly C is positive, therefore limit R, but limit R power n equals 0, therefore limit x power n equals 0. Okay. So this is an important theorem. So by using this theorem, we can solve some problems. That is, find the limit of n by 2 power n. Find the limit of n by 2 power n and